Sup nerds, welcome to the first week of Sigma Science Q&A. My name is Chris, I'm Director and Teacher of all classes at Sigma Science Education in Parramatta. If you haven't already downloaded the questions in PDF format, please visit the website www.sigmascience.com.au, click on the resources menu and it will take you to the week 1 questions that we're working through today. So now, let's solve some problems. Alright, so let's have a look at question 1. So here we're confronted with a scenario that, well, these two pulleys, they kind of look the same. On the left hand side you've got the 75 Newton force, on the right hand side you've got the 100 Newton force, and you're kind of lulled into thinking these are actually the exact same scenario. But I do want to show us that there is a bit of a difference. Okay, so with the pulley on the right hand side, the 75 Newton and the 100 Newton sigma, well, they make up a system. Whereas on the right hand side, the 75 Newton sigma itself is the system, and the 100 Newton force being applied to that system is an external force. So let's look at this scenario in terms of free body diagrams. So for the pulley system on the left hand side, we can consider the 75 Newton sigma as having two forces acting on it. We have the 75 Newton weight force acting down, and then we have the tension in the string acting up. Okay, and we can consider the 100 Newton sigma on the right hand side having a 100 Newton force acting down, and then the same tension force T1 acting up. Alright, so now what we do is we consider expressions for the forces acting on either free body diagram. So we look at the one on the left hand side, and we're expecting the left hand side to accelerate up. So it'd be fair to say that T1 minus 75 is going to be M1A, where M1 is the mass associated with the 75 Newton sigma. Okay, and we can do the same thing for the right hand side. Now we're expecting the right hand side to accelerate downwards. So the 100 should be the greater force, minus T1 is going to be M2A. Okay, where M2 is the mass associated with the 100 Newton sigma. So if we figure out what M1 and M2 actually are, so M1 is just going to be 75 divided through by 9.8, which gives us a value of about 7.65 kilos. M2 is going to be 100 newtons divided by 9.8, which gives us a value of about 10.2 kilos. Okay, so what I have now is basically got everything that I need to solve my equations. I just have A left as an unknown. Okay, so let's plug in the masses which we just figured out. So we've got T1 minus 75 is equal to 7.65A. And we've got 100 minus T1 is equal to 10.20 times A. Okay, easiest thing to do with these two equations is just add the two together. So we end up with 100 minus 75 is equal to 17.85 times the acceleration. Okay, so here we figure out the acceleration, which is going to be 25 over 17.85, which gives me an acceleration of about 1.4 ms to the minus 2 for the pulley system on the left hand side. Awesome, so we've now figured out the acceleration of pulley system 1 is 1.4 ms to the minus 2. Now we're focusing over here on pulley system 2, which is the one on the right hand side. You see the 75 Newton sigma. On the left of the pulley you see 100 Newton applied force. On the right hand side of the pulley, it's the same kind of approach. We just consider this by using a free body diagram. Okay, so our free body diagram, we would have essentially the 75 Newton force from the 75 Newton sigma acting down, and then we have the tension force, but the tension force is simply just being applied by the 100 Newton force applied to the right hand side. Okay, so looking at it like this, it's pretty obvious to see that the net force acting on the object is just going to be 25 newtons. Okay, so we can say the net force is 25 newtons. Okay, now whereas the 25 Newton net force is causing the acceleration of the entire system on the left-hand side, it's only causing the acceleration of the 75 Newton sigma on the right-hand side. Okay, so to find acceleration, we need to say A is equal to F net on M. Okay, where again the net force is just that 25 Newton force, and now our mass of the 75 Newton object is just 7.65 kilos. So this gives us an acceleration of about 3.3 ms to the minus 2. Okay, so now we've found our two accelerations. I mean, it's pretty obvious, what's going to happen. It's going to be the one on the right-hand side is going to strike the pulley system first, but we need to go about proving that. Okay, so to prove that, legit all we do is we just use some of our Suvat equations. Okay, so the Suvat equation, which is going to be useful in this scenario, is just S is equal to ut plus half at squared. And now the displacement in both scenarios is just going to be at 10 centimeters, so 0.1 meters. Okay, so let's figure it out for the first system, the system on the left-hand side. So S is equal to ut. Now it's initially stationary, so ut is going to be equal to 0, plus a half times the acceleration, which we figured out, of 1.4 t squared. Okay, therefore, t is just going to be square root of 0.2 over 1.4, which is going to give us a time of about 0.38 seconds. So that's saying that it takes the 75 Newton sigma on the left-hand side 0.38 seconds to actually strike the pulley. So let's figure it out for the right-hand side. Same equation. So S is equal to ut plus half at squared. Again, S is the same, 0.1. Ut is again 0. So plus a half times our acceleration, which we figured out is 3.3 t squared. So therefore t square root 0.2 over 3.3, which gives us a time of about 0.25 seconds. Alright, so we've got our two values for the time taken for the 75 Newton sigma to strike the pulley. The second part of the question says to account for your results. Okay, so I mean really the calculation is kind of accounting for the results, but the bit of the explanation which we need is essentially the net force. In both scenarios, the net force is more or less 25 newtons. Okay, it's just that on the left-hand side, the net force is causing the acceleration of the entire 100 plus 75 Newton system, whereas on the right-hand side, that net force of 25 newtons is just causing the acceleration of the 75 Newton sigma. Okay, so we can say, therefore, it takes a longer time for the left-hand side pulley system as the weight force on the left-hand side pulley system is greater than the weight force of the right-hand side pulley system. Therefore, the acceleration of the left-hand side pulley system, A1, is less than the acceleration of the right-hand side pulley system, A2.